Hello, we are Team 8, Team J Kwezi, and we're here to talk about our solutions for regional flooding in Nigeria.
So before we go to our solution, we just want to give a background about Nigeria itself. So first we will discuss demographics of Nigeria. Nigeria is about 2 times the size of California. It is the most populous nation in Africa and ranks 7th in the world. As of July 2014, the population was a little bit over 177 million people. This high population can be due to a number of reasons, primarily the high growth rates at 2.54% and the high fertility rate at 5.3 children born per woman. Nigeria also has a very young population with the median age of only 18 years. English is the official language of the country. However, there are over 500 other indigenous languages within the country. The average life expectancy in Nigeria is 52 years, and just over half the population has access to potable water and appropriate sanitation.
In order to get a better understanding of the situation and circumstances surrounding the 2012 Nigerian floods, it is imperative that we have a clear understanding of the political and economic backgrounds during the period. Nigeria is a relatively new country as it gained complete independence from the British only in 1960. However, it did not immediately gain independence in the truest sense. For decades after 1960, it remained politically unstable because of internal conflicts and civil wars. It was only in 1999 that they finally decided to unanimously establish a democratic form of governance. All of which suggests that Nigeria's path to true freedom was not so easy and rather slow. However, economically, Nigerians have been strategic and have been able to monetize on their natural resources rather quickly. Over the last 2 decades, Nigeria has worked its way up to being the largest economy in Africa. It has even surpassed the levels of economic development of South Africa, which most economists consider commendable. Like some of the other countries in the like some of the countries in the Mideast, its oil reserves have been the greatest contributor to economic growth. It is also one of the fastest growing telecommunications markets in the world, with over 112 million users and growing as we speak, which consists of 64% of the nation's population.
The summer 2012 flood of Nigeria was the worst flooding in over 50 years. The flood ultimately affected over 7.7 million individuals through relocation, destroyed crops, and the destruction of infrastructure. Over 14,500 square miles of land were directly affected by the flood along the Niger and Benue rivers, as well as the heavily populated delta in the south. The primary long-term effects of the damage is the destruction of villages and the consequential relocation of people. 363 people died as a direct result of the flash flooding, and there is a significant decrease in available food due to crop destruction. Much of this could have been avoided with a better response by the government and recovery organizations. This is a picture of one of the many villages affected by the 2012 flood.
So, looking at the responses, we notice a lot of fatal flaws in the way the Nigerian government actually took this flood and its response. We mainly see the problem in building of houses in near natural waterways in places that are vulnerable to floods and lacking of a good drainage system in the country. Much of the damage, actually, though, we've discovered was due to a lack of information and a lack of notification of the fact that there was a flood and the fact that there was a state of emergency by the aforementioned president. This lack of adequate information led to indecisiveness in the action, and therefore response was late and delayed.
So we have broken down our solution to address each phase mentioned in the case challenge. This project overview will give a brief look at each phase before delving more into each respective phase. So to help with mitigation efforts, we intend on using a real-time rain gauge mapping technology that can detect initial flooding. This system would produce data that can lead to early response efforts. So the picture below shows an example of a map with real-time data of various sensors using this technology. To deal with response efforts, in the situation that there are signs of flooding produced by the rain gauge technology, LiDAR technology, which we will describe later, will be used to map out the targeted areas for potential flooding. Using LiDAR's results, emergency responders can be deployed as necessary to help move people out of soon-to-be affected areas into safer areas to prevent casualties. And to continue with the recovery effort, in the long term, we aim to address the issue of a lack of sufficient data regarding floods, particularly on location, timing, and water load of these floods, and also improving quality and quantity of this data.
The first phase before any natural calamity is mitigation. Mitigating a flash flood is simply not in human control. It belongs in the category of earthquakes or volcanic eruptions wherein human intervention can do no real good and can at most provide extra time. When we talk of solutions for mitigating such a natural calamity, we are referring to mitigation or the avoidance of deaths or casualties caused by it. And as far as the predictability goes in a situation like the 2012 floods in Nigeria, we are confident that with existing satellite and on ground technologies, floods can be predicted to a high level of accuracy. They were simply not readied or used to deal with this occurrence, which is a clear sign of negligence on the part of the local government. Accurate weather data is also made readily available online through the websites of various weather or climate monitoring organizations throughout the world. One of the IT solutions that we came up with during our process of investigating the Nigerian floods is rain gauge mapping. It revolves around the ideology that primary information during a natural calamity, like flash floods, is essential to saving lives. Strategically measuring rainfall amounts and monitoring water levels in bays and major streams using gauge stations on a real time basis to inform people of dangerous weather conditions has proven to be the most reliable solution used in several developed countries. The gauges also measure wind speed and direction, barometric pressure, air, air temperature, road temperature, and humidity, and communicate with central weather monitoring agencies using laser transmitters and detectors. Such data can be instantly visualized and displayed on a public website, and consequently, messages can be sent to people in the concerned areas by pushing them through cell towers the same way Amber Alerts are sent for missing children. Such level of information sharing can be beneficial as it will allow the people of as it will allow the people to be mentally and physically prepared for the situation and may also facilitate in the search and rescue phases.
So in order to facilitate our response efforts, we plan on using LiDAR technology, as previously mentioned. LiDAR stands for light detection and ranging, and it is a sensing technology that is used to examine the Earth's surface. In our solution, it will be used to gather data and examine locations within Nigeria by mapping these various areas, in this case for flooding. Currently, the weather predictions used are too area general, meaning that flood predictions are given for a general area. This can cause problems because it may not inform people where to go, nor does it provide information on the flow of floods to and from specific areas. For example, these weather predictions can't tell whether a house or school or a specific area of a town will be flooded or not. LiDAR technology comprises of a laser, scanner, and a special GPS receiver that mainly uses light pulses to create a very precise and detail-rich map of the Earth's surface and elevation points on the surface. These maps can show seafloor or riverbed elevations that can be used for these emergency flood response efforts. Given this mapping and data on elevation, accurate computer models can be generated to predict the flow of flooding and also provide information on how long it will take a flood to reach and affect specific areas. The beauty of LiDAR is that we can predict flood activity before a flood reaches a certain area to prevent casualties. When the aforementioned rain gauge mapping system alerts of potential flooding, an aircraft or helicopter equipped with LiDAR technology will be deployed to that area to map. Based on the data produced, alerts and emergency responders will be sent to appropriate areas, as will be described in the next phase. This image shows an example of mapping that can be produced by LiDAR technology, and the following image shows an aircraft equipped with the technology mapping a specific area.
All of this data collection is to inform response teams as quickly and accurately as possible to start mobilizing relocation efforts as soon as a flash flood is detected. The rain gauging system will provide the first signs of the flash flood, and government and military officials will be notified of any dangerous increase in rainfall. If the rainfall increase is significant, a first warning SMS will be sent to areas in possible immediate danger. In response to the increased rainfall readings, LiDAR mapping helicopters will be deployed to assess the situation. The LiDAR mapping information, as well as the measurements from the rain gauges, will be enough to inform the actions of response teams as to where they need to be deployed, and if necessary, more SMS messages will be sent to areas at risk of flooding. During the recovery process, recovery teams can report information to the primary website with updates on the locations to which they've been deployed. These first response teams will primarily consist of the Nigerian military and the Nigerian Red Cross.
Aside from helping response teams with real-time data, we'll be looking to aggregate and collect this data over time. In the 2012 floods in Nigeria, one of the biggest problems was dissemination of information and getting the word out to people that the flood was happening and that there was a state of emergency. We'll be using this data to help those efforts and to help map and mitigate future floods. We'll be able to map vulnerable areas in Nigeria, and we'll also be able to help government relocation efforts as well as engineering efforts to place government buildings and schools above the flood levels. We'll also be able to help improvements on the drainage systems, which were lacking in the 2012 floods as well. Thank you very much for listening to our presentation. We are Team 8, Team J. Kwesi.